Okay, this is part two. This is called waste reduction. And a lot of these might seem like no-brainers, but don't take them for granted. We need to think about their inputs and outputs into our ecosystem. So we're going to start with recycling, process by which certain waste materials are processed and converted to new products. It's one way to reduce current global demand on minerals, but this process is energy intensive and can be costly. So this is not going to fix all of our problems. So we need some other ideas and solutions for the waste that we do have. We have composting. It's the process of organic matter such as food scraps, paper, yard waste, decomposing. The product of this decomposition can be used as fertilizer. The drawbacks include odor and rodents. So there are things to discuss here. E-waste is really essential because you've learned a lot about heavy metals and neurotoxicants and et cetera, and endocrine disruptors. E-waste contains a lot of these materials. It can be reduced by recycling and reuse, and e-waste will include anything from cell phones, computers, any electronic waste. It contains hazardous chemicals, specifically heavy metals such as lead and mercury. This is our neurotoxicant, teratogen, endocrine disruptors, right? Which can leach from landfills into groundwater. And this is what's important about dumps versus sanitary landfills. We don't want materials from these e-waste products to leach into our groundwater. So we line these things with like a nice plastic or clay or both, and we have a leachate collection system, if you recall. So we need to make sure we're disposing of these things properly. And landfill mitigation strategies range from burning waste for energy to restoring habitat on former landfills for use as parks. Now, the combustion of gases produced from decomposition of organic material and landfills can be used to turn turbines to generate electricity. So if we're doing this, we might as well do this intelligently. And this also reduces landfill volume. All right. So reducing consumption is the most sustainable because it decreases natural resource harvesting and the energy inputs to creating packaging and shipping goods. So really reduces maybe the most valuable one. If we can find ways to reduce the amount of materials we're producing, we have less to worry about down the line. So this is our first defense here. Okay, metal, reusable water bottle to reduce plastic use, riding a bike or walking to reduce gasoline use. Reusing is the next most sustainable because it doesn't require additional energy, right? So recycling is energy intensive. It's not a solution to everything. It's probably our last of these three. All right, and then lastly, buying something. Not lastly, so reuse secondhand clothes, reusing old wood pallets for furniture, washing plastic takeout food containers and reusing them, and then recycling, converting solid waste into new products. So we don't necessarily have to mine for new things, right? Um, Ideally, if we can have a closed loop system in which every bottle is returned and we reuse these in such a way, that could be great. We don't necessarily have to process as much. But it's complex and it can be unreliable. Um, so there's a lot of different ways to do this. You can even get clothing made out of plastic now, which is actually quite comfortable. Interesting, right? The least sustainable of the three are due to the amount of energy it requires to process and convert waste materials. So reduce is our best option. Reuse second best, and recycling are third best. So know specifically the pros and cons. Recycling is not, as many people think, perfect. I'm sure a lot of people don't think that, but reduces demands for new materials, especially metals and wood. And we know about mining and the cost of mining and clear cutting, etc. This can cause habitat destruction and soil erosion, as well as the leaching of metals and toxicants into groundwater from mining, right? So there's a lot of consequences to producing new materials from scratch, right? So it is better than just mining for new materials. Reduces energy input to ship raw materials and produce new products. Fewer fossil fuels for shipping and mining, etc., and chopping down trees. Less climate change. So it saves energy, right? Reduces landfill volume, which is also a problem, and conserving landfill space and reducing the need for more landfills. That's good. But what's the cost? Recycling is costly and still requires significant energy. Cities that offer recycling services need to process, sort, and sell collected materials. Prices change rapidly, leading to recycled materials often being thrown away. So when citizens recycle items that shouldn't be recycled, wrappers with food, styrofoam, etc., it increases the cost for cities to sort and process. Our global plastic waste by disposal, recycled, incinerated, discarded in 1980, almost everything was just discarded, thrown away. I mean, see, right now that's less than 60%, not quite 50% of everything is thrown away. So we still got a long way to go. Incineration, we'll discuss in a little bit, but this is still energy intensive and not necessarily the most efficient. So if we have new ways of making materials that are easier to recycle, making this easier for people to recycle and to understand what is recycling, what's not, this could be a better system. Composting is also good. Sort of like organic recycling, right? Organic matter, food scraps, yard paper waste are decomposed under controlled conditions. This also reduces landfill volume and produces rich organic material that can enhance water holding capacity, right? Think our loam, it's a mixture of sand, silt, and clay. This will help nutrient levels in agricultural gardens and soils. It produces a valuable product to sell. A lot of people like organic compost, and it reduces the amount of methane released by anaerobic decomposition of organic material in landfills. This is important. Remember that landfills are really compressed. There's not a lot of oxygen in there. So you have bacteria that are anaerobic that function without oxygen. Um, Proper mix of browns to greens. This is carbon to nitrogen, etc. It should also be aerated and mixed to optimize decomposition. So you need to mix this often. Make sure we're having the maximum amount of decomposition here. Okay. Um, Now this can be smelly, and if you just have sort of an open composting bay, you can attract certain organisms like rats, raccoons, etc. So there are ways to get around this, but know that this, if not done properly, can have a certain smell if not properly rotated, and rodents and other pests may be attracted to this as well. So we take waste, grind it up, sort it, take it to raw material storage, where it decomposes for a while. We mix it, we screen it. We have our little composting bays, and then we have active composting, and we just continue the process here. Allow this to cure and decompose further. We screen it more. We store it for a little while to let it decompose a little more and aerate out, and then we have our compost. So that is composting. E-waste is a really important one, and this has come up regularly on the AP exam. Lead and mercury, you should know methyl mercury by now. You should know lead by now. Cadmium itself is a neurotoxicant as well. A lot of these metals are put into our e-waste, printers, computers, desktops, cell phones, etc. And we're using a lot of electronics these days, so it's a really essential thing to understand. These toxic metals can leach, it means water flows through them and picks up these heavy metals, and then they now are basically piggybacking with that water into our groundwater, especially in an open dump where there is no clay or plastic lining. Landfills, sanitary landfills may be a little better, but it's still a concern. This can be recycled and reused, which is good news. A lot of places like Target and Best Buy will have places where you can recycle these things. So if you have an old cell phone, don't throw it away, right? That's a really important thing to not throw away. But these are often sent to developing nations for recycling due to health hazards and more strict environmental and worker protection laws in developing nations. So there is a discrepancy here in equity if we're talking developing and industrialized nations. So um, yeah, something to consider. This can be considered a con. This can be dismantled and sold to countries that extract valuable metals like gold, silver, and platinum from motherboards, but they're often burned or dumped due to less strict environmental regulations. So one way to get around the costly, and coming back to this, the costly process of properly recycling these is to sell them to countries that don't have these strict environmental laws to protect people and the environment, which is, again, inequitable, right? Often burned or dumped, less strict regulations or lack of enforcement in developing nations. All right, so these are places that might not have the laws that require sanitary landfills, and open dumps might just work just fine. But pollution does not have political borders, so it's important to recognize that anything that leaches into groundwater will eventually make its way into ocean, or anything that's incinerated will make its way into the atmosphere, and the atmosphere deposits methyl mercury and lead far from its burning site regularly. right? Waste can be incinerated, burned to reduce the volume and also generate electricity. Paper, plastic, food that creates hydrogen. Know your outputs: hydrogen, carbon, and oxygen. That's what they're made of, so they combust at high temperatures. The same process burning coal, natural gas, and biomass. No different than anything else. We are burning this waste. We have a boiler. We're turning water into steam. We're spinning a turbine. Turbine rotates a generator, and we have electricity. And then we have our waste that comes afterwards. Now, this is biomass essentially. So there are the same products as well. We have emissions. We are always going to have nitric oxides, and we might have carbon dioxide for sure. We might have other materials depending on what it is exactly that we're burning. Methane gas produced by the decomposition in a landfill. This is another thing. Remember that methane gas, CH4, the reason this is happening is because this is so compressed. We're not having aerobic digestion in which we're creating carbon dioxide. We're having anaerobic. Anaerobic means, without oxygen. So bacteria that don't require oxygen are decomposing this material because there's no oxygen here. And they produce, instead of carbon dioxide, they produce methane. So we have methane collection systems rather than letting this go directly into our atmosphere. We can use some of this methane as well for electricity generation. So our landfills can actually generate some electricity. Now, burning methane will create carbon dioxide and will create nitric oxides. It's the same as any other process. And then it creates steam that turns a turbine that rotates a generator that creates electricity. Same as everything else. This does reduce landfill volume. It produces electricity without fracking or mining for fossil fuels, but it is producing methane. However, methane is being produced anyway. Why not use it, right? This is a sample math FRQ problem that we're going to be reviewing much more heavily. And as an example, this is a specific e-waste question, but this is a calculation question that we expected to know percent increase of mobile devices from 98, in which we had 30 million, to 2007, which we had 180 million. And then the number of grams of gold that were used in the production of these mobile devices, if 0.03 grams of gold were found in every device, and there are 180 million of them in 2007. So a sample question that we're going to address later. But here you go. So don't take this for granted. Know the inputs and outputs, and know the benefits and consequences of these.